again, Year 6, it's that time of day where we are thinking about our arithmetic. Now, hopefully you've already had a go at today's arithmetic questions and you're ready to sit and mark with me today. So make sure you've got your work in front of you and a pencil. Don't forget you can pause the video as we go through if you want to do any editing, just like we would in school. Now I'm going to start with the lower key stage questions and then I'll go on to the Year 5 and 6 questions. You might want to fast forward to about halfway through, and then that way if you're just doing the Year 5 and 6 questions you can sort of sit for a shorter length of time. Okay, let's get started then. So lower key stage questions, number 1. We've got 285 subtract 34. Now, if I'm not feeling confident with doing this mentally, I could use, or if I sort of need a stepping stone to be able to doing it mentally, I could use a number line to help me. So I've put 300, that's going to confuse us, isn't it? Let's start again, everybody. 285. So I've put 285 on my number line, and I know I'm subtracting, so my answer is going to be smaller. Now I'm subtracting 34. And if I was to split 34 into its parts, how many tens are in this number? That's right, we've got 3 tens or 30. And how many ones? Well done everybody, we've got 4 ones. So I've split 34 into its 2 parts to help me. Now looking at this number, I could subtract 30 quite easily. I've got 80 tens in this number, so 80 subtract 30 would be 50. I haven't subtracted anything from the hundreds, so 250. Okay, so I've subtracted that part. Now I'm going to subtract the last part, which is 4. 250 subtract 4 is 246. So hopefully you've got that one right today and you can give that a neat little tick in your book. Okay, number 2 then is 9 multiplied by 3, or 9 lots of 3. So again, I've done an array here, and some of you may have done an array at home. So at the top I've got 1 lot of 3, 2 lots of 3, 3 lots of 3, 4 lots of 3, and 5 lots of 3. What's happened Year 6, sorry? I haven't done my array big enough. Now I've seen lots of you doing this at home. You've not counted your array carefully. So at the moment this array stops at 5 lots. 1, 2, 3, 4, 5. So I need to add on my 6th lot, my 7th lot, 7th lot of 3, 8th lot of 3, and then my 9th lot of 3. Okay, now I've got 9 lots of 3, and I'd be able to count those to know that 9 times 3 is 27. Okay, let's have a look at question 3 together then. We've got 7.7 add 1.4. Now some of you might be able to do that mentally, others might need to use a place value chart to help them. So I've got 0.7 add 1.4. So I'm using the place value chart just to help me check that I've lined the ones up correctly and the tenths up correctly, and that my decimal point is also in line with each other. So I've got 7 add 4, which is, and you'll notice I'm pausing there Year 6 to give you a chance to join in with me at home and to work it out as well. 7 add 4 is 11. Okay, 7 add 1 is 8. Add the one I've carried is 9. Don't forget to put your decimal point in, 9.1. Okay, number 4 then. And I'm just about to rub this out Year 6, so if you need this, make sure you pause your video now. Let's move this out the way for us. So number 4, we're doing 45 divided by 9. Now I'm going to use my 9 times table to help me with this because I know my 9 times table. I know that 9 multiplied by 5 is 45. And because multiplication is commutative, I also know that 5 multiplied by 9 is 45. So therefore, if I want to know how many 9s there are in 45, I can use this knowledge to help me. There are 5 lots of 9 in 45. So 45 divided by 9 is 5. Give that one a neat little tick if you've got that one this morning. Okay, let's have a look then at 1/4 of 24. Now, we know a quarter, if I had a chocolate bar, I'd have half. This would be the same as having half. I've got 2 halves of my chocolate bar. We know a quarter would be 4 equal pieces. I haven't done that very equally, have I, year 6? 1, 2, 3, 4. Now, if I was to colour one of these in, or to eat that up, if it was a chocolate bar, knowing me, then I would have eaten or drawn in 1/4. Now, to find a quarter, I could find half first of all. That would help me. So half of 24. So that's the same as dividing by 2. Now I can do that quite simply because half of 20 is 10 and half of 4 is 2. So half of 24 is 12. So I've worked out half of my chocolate bar, but I only want a quarter. So if you think about half, I need to half it again to find a quarter. So I need to do 12 divided by 2, that's the same as halving. And I know half of 12 is 6. So just to recap year 6, a quick way of finding a quarter is to half and then half again. So 1/4 of 24 is 6. Okay, let's go down then to our flashback. Now our first flashback is 6 multiplied by 3, or 6 times 3. We know it's commutative because that could be the same as 3 times 6. Okay, so 6 times 3 is 18. Brilliant. Now some of you may have drawn an array at home to help you. That's absolutely fine. Hopefully you've got 18 and you can give it a neat little tick. If you haven't, go back to your array, check that you've done it correctly, you haven't missed out any rows or any counters. Okay, if you have made a mistake where you've been counting up in 6s or 3s, go back and check. Okay, now we've got a word problem here, so we know we use UDC to help us. Underline, draw and calculate. So I'm going to read through the question. As I read through, I'm going to underline the important information. A racetrack is 3 kilometres long. Now, I'm not going to underline racetrack because it doesn't actually matter what's 3 kilometres long at this point, but I know something is 3 kilometres long. Whether it's a racetrack or a piece of string, doesn't matter. A car does 100 laps of the track, so they go round 100 times. How many kilometres does the car travel? So how far does it travel? Right, I'm going to draw a little picture to help me understand this. So I've got a racetrack and the whole thing totals 3 kilometres. The car does 100 laps. That means it goes round 100 times. So how far does this car travel? So I've got 3 kilometres multiplied by 100. Now when I'm multiplying by 10 or 100 or 1,000, what do we use year 6 when we're at school or when we're at home? We can use the same thing. What do I use to help me? You're absolutely right. I go back to my place value chart if I need to. Some people will be able to do that mentally, but if you're somebody that finds it tricky, pop your 3 in the ones. When we're multiplying, we're making the number bigger, so that tells us we're moving to the left on our place value chart by 100, so that's 2 places, so 1, 2. I've got no 10s, so I put my placeholder in, and no 1s. So he travels 300 kilometres. And you can shorten kilometres to km. Okay, let's make sure that looks like a 0. Right, now we're on to question 3. So we have a rectangle. I've drawn one down here to help us. So a rectangle is 8 centimetres long and 5 centimetres wide. What is the perimeter of the rectangle? Okay, so I've done my picture. Now, if you think about UDC, I've underlined. Now I've drawn my rectangle. I'm going to put some information on it to help me. So I know this side is 8 centimetres, which tells me automatically so is this side. It's 5 centimetres wide. Now we know a rectangle with its parallel lines, this is the same length. Okay, perimeter then. How do I find the perimeter of a shape? Well done, perimeter is the outside length. So to find the perimeter, I'd have to add all 4 numbers together. So 8 add 5, add 8, add 5. Now there's probably a quicker way to do that. Some of you are looking at that thinking, well, I know 8 and 8 is 16. That's a number fact I know. 2 lots of 8. And I know 5 and 5 is 10. 2 lots of 5. And I know I can add together 16 and 10 really easily to give me, or mentally I should say, to give me 26 centimetres. So the perimeter of the rectangle is 26 centimetres. And you'll need the centimetres, the unit of measurement, to get it correct. So if you've forgotten it, don't forget to go back and put it in. Right, we're on to some rounding then, and we're getting good at this. I've been impressed with our progress on Class Dojo. So we're going to round 352 to the nearest 10. So when we round to the nearest 10, we find the tens digit. So the 5 in this number is representing the tens. If you're not sure, draw a place value chart. 1s, 10s, 5 represents the tens. So once you've found the tens, you look next door. 0, 1, 2, 3 or 4 tells us to stop. The 10 stays the same. All digits before stay the same and all digits after become a 0. Okay, so that's one way of rounding to the nearest 10. Some people prefer to use a number line if you're a little bit more of a visual thinker. So if I've got 352 on my number line, the multiple of 10 that comes before is 350. What's the multiple of 10 that comes after? What's the next multiple of 10? 360. So is 352 closer to 350 or closer to 360? You're absolutely right, closer to 350. So if you've got that one right, give it a neat little tick. Okay, don't forget to share your work with me if you've been doing the lower key stage questions. Okay, I'm really looking forward to seeing your progress today. And stay with me now if you're on to the 5 and 6 questions. Okay, so our first question then is 3,888 divided by 16. Now, if you don't feel confident with your 16 times table, your multiples of 16, then I would start by writing them out and taking some time to do that carefully this morning or this afternoon. Sorry, I just needed a drink there, year 6. Been doing lots of talking, haven't I? So I've written out the multiples of 16 here. 16, 32, 48, 64, 80. That's going to help me complete this calculation. So I start by thinking, how many times does 16 go into 3? Well, it doesn't, so I put a 0 up there. And I carry the 3, or I exchange the 3 across. So it now represents 38. So I've got 16 into 38. And this is where our multiples come in handy, because I can go down my multiples and I think, okay, 32 is close, 48 is too far. So the closest I can get is 2 lots of 16. But I know I'm going to have remainders because that only takes me to 32, and I was thinking about 38. So I'm going to count on, and you can use your fingers if you want to, if you find it easier, 33, 34, 35, 36, 37, 38. So I've got a remainder of 6. Okay, some of you might have been able to find the difference just by doing a subtraction in your head, and that's also fine. Now we're doing 16 into 68, and again this is where your multiples come in handy. We're going to go down our multiple list. 16, 32, 48, 64, well, that's close. 80 is too far, we've gone past our 68. So 64 is as close as I can get. So 1, 2, 3, 4. It goes 4 times exactly, with how many remainders, year 6? Well done, everybody that's counted on 4 remainders. So now we're thinking about 16 into 48, and again this is where my multiples come in handy. 1, 2, 16 times 3 is 48 exactly, so my answer is 243. If you've got that one, give it a neat little tick. Right, that brings us on to our fractions, and we've done lots of work on fractions at school. I know some of you are still feeling a little bit nervy of them, so follow along now and see how you got on. But we were making lots of progress, so don't give up year 6. Even though we're at home, still continue to try and challenge yourself to have a go at these fraction questions. Now, when I'm subtracting fractions, or I'm adding fractions, the first thing I look at is the denominators, that bottom number. So I've got 15 sixteenths, I'm looking at that bottom number, subtract 3 eighths. And I notice they're different. What do we know about the denominators? What do they have to be before I can subtract? Brilliant, they have to be the same. So I've got to convert these fractions so that they have the same denominator, the same number on the bottom. Now I know my 8 times table, so I know 8 multiplied by 2 is 16. So if I do 8 times 2, I get 16. And that means then I've got the same number, same denominator. Now, because I multiplied 8 by 2, I've also got to multiply 3 by 2. So 3 times 2 is 6. So I've converted this fraction. They are exactly the same. They represent the same amount. Okay. All I've done is I've converted it. So 3 eighths is the same as or equal to 6 sixteenths. Now, I don't need to do anything to this fraction because it's already got the denominator of sixteenths. Okay. Now I've got the same denominator then, year 6. What can I do? You're absolutely right. I can do 15 subtract 6, which is 9. And we know the denominator remains the same. It's 9 sixteenths. Okay, what question do we ask ourselves at this point, year 6? Well done, everybody. Can we simplify? Is there a number that divides into 9 and 16 equally? Well, 2, no. 3, well, 9 divided by 3 is 3, so that divides equally, but 16 doesn't divide by 3. 4, do they both divide by 4? No. 5, no. 6, no. 7, no. 8, no. 9, well 9 yes, but 16 isn't in the 9 times table, doesn't divide by 9. And 10, no. 11, no. 12, no. So we know this fraction is in its simplest form. So you can give it a tick if you've got that one. If you haven't, I suggest you pause the video now, Year 6, and trace back through your steps to see if you can do any editing and see where you went wrong. Okay, on to number 3 then. Number 3 is 4,635 multiplied by 37. So I've set up my multiplication. Now you've done lots of these at school, Year 6, so I'm going to go through this one quite quickly so you're not hanging around waiting for me. So 5 times 7 is, well done, 35. Then we go on to 3 times 7, which is 21. Add the 3 we've carried is 24. Then we're on to 6 times 7, which is 42. Add the 2 we've carried, 44. Then we're on to 4 times 7, which is 28. Add the 4 we've carried, 32. So we've multiplied everything by the ones, which means we're now into the tens column, and this 3 represents 30. So we're showing now that we're into the tens by putting our placeholder or our tens unit there. So we start by doing 5 times 3, which is, great stuff, 15. And then 3 times 3, which is 9. Add the 1 we carried, 10. 6 times 3 is 18. Add the 1 we've carried, 19. And 4 times 3 is 12. Add the 1 we've carried is 13. And then finally we add together our 2 answers so far. So 5 and 0 is 5. 4 and 5 is 9. 4 and 0 is 4. 9 and 2 is 11. 3 and 3 is 6. Add the 1 is 7. And then 1 on the end. 171,495. Okay, great stuff, Year 5. Again, give that a tick if you've got it. If you know that you've made a calculation error somewhere, go back and see if you can spot it, and then send it to me on Class Dojo, and I can see how you've been getting on. Now, we are on to 73% of 60. Now, there's a few different ways that you can do this, Year 6. I'm not going to show you all of the ways now, because that would take far too long, but I'm going to show you the way that I think most of you have probably done it at home. Okay, if you've got another method, please do send it to me on Class Dojo. Now, I'm going to think, what do I already know about percent? Well, I know percent is out of 100. I know how to find 10%. How do I find 10% of a number, Year 6? Absolutely right, I have to divide by 10. So I know how to find 10%. Is there anything else I know how to find? Well remembered, everybody. We know how to find 1%. How do we find 1%? You've got great memory today, everybody. We have to divide by 100. Okay, so if I know those things, I can use that to help me find 73%, because I can find 10% first. And to find 10%, what do we have to do? Let's go up to our reminder up here. 10%, we divide by 10. So 10% of 60 is 6. Well done. Now, if you don't know how to divide by 10, don't forget to draw your place value chart. Okay, put your 60 in. Divide by 10, we're making it smaller. Move one place to the right. We've got 6. Okay, so I found 10%, but I actually want 70%. We know this 7 here represents 70. So how could I use this knowledge to help me? Well, I know that if I was to times 10 by 7, I would get 70%. So if I want to find 70%, I need to multiply by 7. So 70% of 6, or 6 times 7, is 42. So I now know that 70%, I should say of 60 there, sorry, 70% of 60 is 42. Now that just leaves me to think about the 3%, but I know how to find 1%. So if we think about 1% now, so 1% of 60, how do I find 1%? We know, don't we, to find 1% we are dividing by 100. So what is 60 divided by 100? And if you need to use a place value chart, don't forget we're really experienced at this, aren't we? This isn't, place value chart isn't new stuff. We've been doing this for a long time. So I've got 60 dividing by 100. So I move everything over 2 places to the right, put my decimal point in. 1. Oh, I've done too many zeros there, haven't I, year 5? There you go. Really experienced at this, aren't we? So we go 1. Oh, no, I have. Gosh, do you know, I don't know what I'm doing here, yes. And I've called you year 5 again, haven't I? Got myself in a flummox. Right, let's start again, shall we? We're finding 1% of 60, and we're dividing by 100. So I've put 60 on my place value chart. I'm now making it smaller, so I'm moving to the right 2 places. Let's go. 1, 2. Let's move my 6 over 2 places. 1, 2. Have I got any 1s now? No 1s. Decimal point. Oh gosh, that's a big decimal point, isn't it? Decimal point always comes between the 1s and the tenths. 0.6. Some of you might have been able to do that mentally, others have used a place value chart. So I know what 1% is, so how can I use that to find 3%? Well, if I multiply 1 by 3, that would give me 3%. So to find the 3%, I have to multiply this side by 3. Now 0.6 multiplied by 3, well, I know 6 times 3 is 18. So 0.6 times 3 will be 1.8. So now I know what 70% is, and I know what 3% is. So I've got 42 and 1.8, and I could add those together mentally. 70 add 3 makes 73, so I've got to add these answers together. So I would get 43.8. So 73% of 60 is 43.8. Now, like I say, there are varying methods to do that. Some of you might have found 1% and then multiplied by 73. That's fine. Some of you may have found the difference and subtracted. That is also fine. I'm really looking forward to seeing what methods you've used today. Okay, I think, oh no, we've got one more to do for our arithmetic. Then we're on to our flashback. So we've got 8/9 divided by 4. And I wonder who can remember what we need to do to solve this. That's right, we've actually got to multiply. So we need to multiply 9 by 4, which is, brilliant, 36. We know our 9 times table. And then our denominator remains the same. We don't do anything to that one. So 8 goes on the top. Now, can I simplify this fraction? Yes, I can. There is a number that divides equally into 8 and 36. Hopefully you've spotted, because you know your 4 times table, that 4 goes into 8 twice, and that 4 times 9 is 36. So 4 goes into 36 9 times, 2 ninths. Now, if you've got 8/36, you would get the mark, that's fine, you'd get a tick. But to stretch our thinking, we always try and simplify where possible. Okay, let's have a look at question 1 then. 6 of our flashback now. 63 divided by 7 divided by 3 equals, or is the same as, something divided by 3 divided by 7. That's going to be 63. We're trying to balance it out to make it the same. If I was to do 63 divided by 7, that would be 9. 9 divided by 3 is 3, so we know that side totals 3. 63 divided by 3 is 21. 21 divided by 7 is 3. Okay, so they both are equal, they're all the same. Okay, question 2 then is asking us to calculate 6,322 multiplied by 14. Some of you might have multiplied by 10 mentally and then by 4, that's fine. Others of you may have done the formal written method that I'm going to talk you through here. So I'm going to go quite quickly through this because we've done this lots. 2 times 4 gave you the answer then, didn't I? Year 6. 2 times 4 is 8. 2 times 4 is 8. 3 times 4 is 12. 6 times 4 is 24, add 1, 25. Multiplied everything by the ones, so now we're moving into the tens. And I put my placeholder in there to represent that. And we've got 1 times 2 is 2, 1 times 2 is 2, 1 times 3 is 3, and 6 times 1 is 6. Then we're adding these digits up. 8 and 0 is 8. 8 and 2 is 10. 2 and 2 is 4, add 1 is 5. 5 and 3 is 8. And 2 and 6 is 8. So if you've got 88,508, give it a neat little tick. Okay, we're on to rounding. We're getting really good at rounding now. You've shown me lots of progress on Dojo. So we want to round 3,099 to the nearest 100. So I've got my number down here ready. Because we're rounding to the nearest 100, I want to identify which digit is in the hundreds column. Well done to everybody who's thinking 0. So I find my 100, I look next door. 5, 6, 7, 8 or 9. We round the 100 up to the next 100. So I've got 0 hundreds in there, so add 100 is 1. All digits before stay the same, and all digits after become a 0. Of course, some people are visual learners and they do like a number line. So if I think about the multiples of 100 here, so if I've got 3,099, what's the next multiple of 100? Well done, 3,199, and the multiple here, oh, hang on a second. Sorry everybody, I had a knock at my front door then, I just had to pause. I'm back with you now. So we're back on our number line. We are rounding, aren't we? 3,099 to the nearest 100. So we wanted to know what the multiples are of 100 that comes before and after. So if I got 3,099, the multiple before is 3,000 and the multiple after is 3,100. So which is it closer to, year 6? 3,000 or 3,100? Well done. rounds to the nearest multiple, which is 3,100. Okay, we're going to move on to our angles question now. And like I said yesterday, we haven't done a huge amount of angles work. So if you're looking at this and you're thinking, oh, I can't remember, I'm not too sure, don't panic, because we've only been doing little bits at the end of the day on angles, and we've got some more learning to do. But hopefully you at least recognise the words, because these are things that we've talked about and we've looked at before. So we want to know, is angle X, so we're looking at this angle here, acute or obtuse? Okay, those are words that we've heard of before. So what does acute and obtuse mean? Okay, let's start with acute. So acute is an angle that is less than 90 degrees. So 90 degrees is a right angle, and an acute angle has to be smaller. Okay, it could look like that. It could be very small and look like that. Okay, it could be very close to 90 degrees and only just be slightly smaller. Okay, so an acute angle is less than 90 degrees. What is an obtuse angle? Well done. An obtuse angle is more than 90 degrees or bigger than 90 degrees. So if we remind ourselves, 90 degrees, the right angle. So an obtuse angle is bigger than 90 degrees. So it could look like this. It might sort of be something like that. Now you'll notice that it's less than 180. So it's more than 90, but less than 180. So we want to know, is this an acute angle less than 90 degrees, or is it obtuse more than 90 degrees, but less than 180? Now, what do you know about the angles in a straight line? Oh, that's not a very good straight line, is it? Year 6. Let's do a popular one. Angles in a straight line, what do they total? Well remembered, everybody. That's something we've definitely discussed lots at the end of the day when we've been doing our little revision sessions. That angles in a straight line total 180. Okay, so I've put that at the top of my bar here. And year 6, you'll be familiar with the bar method. Your parents at home might be looking at that thinking, what's that? So you might need to explain it to them if they're trying to help you. So we've got our total at the top, 180 degrees. We know one angle is 35, so that's one part of our whole. We've got the angle in this sort of middle here, 76, that's another part of our whole. But we don't know what this part of the whole is. That's what we want to try and work out. Okay, we can't guess. Okay, it's not drawn to scale, so we need to use our knowledge of angles. So how do we find this missing part? So a couple of ways to do it. You could do 35 add 76. You could add those up. What would you get if you added 35 and 76 together? 5 and 6 is 11. 7 and 3, add 1 is 11 as well. So we get 111, those two parts. So if those two parts total 111, how do I find this missing part? How do I find what's left over? Well done. We do 180 subtract 111. Okay, some of you might be able to do that mentally. Others of you I know like a method. Some people feel a bit safer with a method. So I'm just starting with my exchange there. 10 take away 1 is 9. 7 take away 1 is 6. And 1 subtract 1 would be 0. So we then know that this part here is 69 degrees. So if X is 69 degrees, then is it an acute or obtuse angle? Well, let's go back to our initial knowledge. An acute angle is less than 90 degrees. Is this less than 90? Yes, it is. So it is an acute angle. Now, don't worry, Year 6, if that's a little bit confusing. All right, we haven't done much work on angles, but it's something that we're going to do together in the future. I know that you'll be familiar with acute and obtuse, and even if you can't quite remember what they mean, you'll sort of look at this and you'll go, oh yes, I know those words. Right, don't forget to send your learning to me on Class Dojo. Have a lovely day, everybody.